Alright, the integral of e to the 5x dx. So let's get our x world set up, our box, and our u world. Alright, so over in x world we've got the integral of e to the 5x dx. Oh, getting ahead of myself. Alright, our u in this case needs to be 5x because the differential will be du equals 5 dx. Okay. Now, if you look at the pieces we need to bring over, I don't need a 5 dx, I just need a dx. So I'm going to move that 5 over and get 1/5 du equals dx. Alright, let's bring our integral in x world through the box over to u world, and we're going to get the integral of e to the u, and then we're going to have 1/5 du. Alright, the integral of e to the u is just e to the u, so we're going to have 1/5 e to the u. That's going to come back through our box to get to x world though, and we're going to have 1/5 e to the 5x plus c. There we go. Alright, last example. This last example was actually an integral that I gave you along with 3 others that I said, these are 4 other integrals that are good to know as one-steps, but they're not necessarily officially on the one-step list in terms of being paired with a one-step derivative. So let's check this one out behind the scenes. Now that we know u substitution, we can look at the integral of tangent x dx. So keep in mind that the integral of tangent x dx would be the same as us finding the integral of sine x over cosine x dx, because tangent is sine over cosine. Alright, so starting in x world, I'm going to treat this integral as the integral of sine x over cosine x dx. It's going to have to go through my box, and we're going to bring it over to u world. Alright, now this one's a little bit tricky in terms of figuring out which u we need to pick, whether we pick sine u or cosine, or sine x or cosine x. But you'll find that if you pick sine x, it's not going to actually give me the piece that I need in the differential. So let's just take a peek at what would happen. What if we let u equal sine x? My differential would then be du equals cosine x dx. Now, it is true that there's a cosine floating around somewhere in the problem, but we don't need cosine x dx, we need 1 over cosine x dx. So this choice of u actually isn't going to work. Okay, so let's go back instead and set u equal to cosine x. Then our differential du would equal negative sine x dx. Now I've got the pieces I need, but we got to make one more slight modification. I don't need negative sine x dx, I just need sine x dx, so let's move that negative to the other side. Negative du equals sine x dx. Alright, through my box, over into u world I go. I'm going to have the integral of 1 over u, because that cosine x, which is my u, is in the denominator. And then in order to bring over my sine x dx, I'm going to bring a negative du. Now, it might help you at this point in terms of, no it won't, I take that back. Alright, integral of 1 over u would be the natural log of u. So we're going to end up with negative natural log of u. Now keep in mind too, when we take the natural log, we need those absolute value symbols there to ensure that our argument is positive. Bring it back through, and we're going to have negative natural log of the absolute value of cosine x plus c. Now, if you compare this answer to the answer that I gave you in your notes the other night, you're going to see that it's a little bit different. Here's why. I can manipulate this a little bit further if I wanted to. There's nothing wrong with this answer, but I could put it into maybe a little bit more of a friendly form. I can get rid of this negative by bringing it up into the exponent position, which is now going to give me the natural log of cosine x to the -1. But that's the same as 1 over cosine x, and 1 over cosine x is the same as secant x. So we're going to have the natural log of the absolute value of secant x plus c. And this was the answer that I gave us in class in our notes. Okay, so I would encourage you go back and see if you can figure out the how and the why of those other 3 one-steps that I gave you in class the other night. I would start with trying the integral of cotangent x dx and see if you guys can get the same answer as I gave you guys in class, but using the u substitution. Okay. When we get back to class on Monday, I'm going to do a couple more examples with you. But other than that, make sure that you're getting started on the homework for this section and practice, practice, practice. Bye.